Hey guys, it's Will here. So today we're going to go over how to architect and design a REST API. So a REST API may sound complicated at first, but it's actually pretty straightforward once you learn like the basic characteristics of it. So first, let's talk about what REST is. So REST is something that stands for representational state transfer, which is a way of transporting data essentially over HTTP across the internet. So the main thing to really get from REST is that REST is a way to transfer resources between server and client. So a resource would be any singular entity within your backend system or your server system or server app, whatever you want to call it. So let's say I have a CRM and its job is to manage all of the suppliers, products, and deliveries and so on for a company. So people can come into the system and they can create different products, different orders, that can schedule deliveries, things like that in the system. And all of these resources are related to one another in a different way. How would you expose that data to the outside world in a way that it can be consumed by a third party? Whether it's, let's say, a desktop app or a mobile app, how would you go about architecting a system so that that data can be either retrieved or updated, or even additional data can be created within the system? How would you go about that? Well, the first thing that we are going to need to talk about is resources, which we just talked about. But the second thing is HTTP verbs. So, like I said, you need to support the capability to create new resources in the system, update existing resources, simply fetch or retrieve existing resources, and maybe delete resources that are no longer applicable anymore. That's where the 4 or 5 main HTTP methods or verbs come into play. So these keywords have very specific meanings within REST. So I'll go ahead and just talk about each one of them now and kind of what they mean and how they're used. So a post HTTP verb or method is a way of creating a brand new resource on the server. So if I'm going to, let's say, create a new customer, or I'm going to create a new product, I'm going to post a HTTP request with a new product as the data that I'm sending along. So that's what post stands for. If I want to then, after I've created that new customer or that new product, I want to display it on the screen for the user, I'll have to somehow get that data back. So what I would do is I would issue simply a GET request, get, which is going to just essentially fetch that data from the server and return it to me in a piece of data, like a JSON payload. A put is the verb that's used to either update or just completely replace an existing resource in the system. So if I have, let's say, a customer who wants to update his mailing address, and I want to go ahead and actually he wants to update not only his mailing address, but let's say all of his data changed. He changed his name, his mailing address, his zip code, and I just need to update all of it. I can send a put request, which essentially will overwrite his existing record with a brand new record of data. So I'll say put customers, I'll give the customer ID, and then I'll send all the data along to kind of overwrite or replace his record in the system. The next verb is called a patch, which is extremely similar to a put, except it has a very specific meaning. So a patch request is a way of just updating a single field of data on an existing record. So let's say I have a customer and I don't want to update his entire record, I just want to update his zip code, for example. I can send a patch request which will update just one single field and then leave all the other traits or all the other fields on his record just as they were, so it will not touch them. It will just kind of leave them the way they were. And of course a delete is pretty self-explanatory. A delete request is just going to pretty much nuke away or get rid of a record on the server. So we went over resources, we went over the HTTP verbs for REST. Now we're going to talk about the status codes. So whenever a server gets a incoming REST call, a request, whether it's a post, get, put, patch, or delete, it's going to return with either it's going to return with a status code and then either a response body like a JSON payload, or it could just not return a body at all. So those are the two main things to remember with a REST calls, that it's going to return with a status code and it's also going to return with a response payload or a data payload. So looking at the response codes, anything in the 200 range is going to be a success code, or essentially a success code. So anything between 200 to 299 is a successful response. So the codes don't go all the way up to 299. They just left that space open for future verbs. But yeah, so anytime you get a 200 series code, you will assume that the response was successful. 300 series, so from 300 to 399, stands for server redirects. So if, let's say, an endpoint has moved to a different endpoint, or the server needs to redirect you to a different page and then bounce you back, let's say to log into the system, and then it wants you to redirect back to the page that you originally tried to go to, that's what these codes are for. So they stand for redirecting the user. 400 and 500 series codes both stand for errors, except the 400 series codes are for client errors. Client errors meaning you tried to send a request to the server and the request was bad because it was something you did. You sent bad data, or you tried to update a user that doesn't exist anymore in the system, or maybe you sent a post user to create a new user, but you were only allowed to create a name with 20 characters and you gave 25 characters. So that would be a bad request of 400. That's what the 400 series codes are for. And then the 500 series codes are server responses. Or server error responses more specifically. So if you get a 500 series code, that means that something pretty bad happened on the server, or you just can't really connect to them. So like a 502 is a bad gateway. So essentially your request didn't even make it to the server. It pretty much died on the way there. A 500 is just an unknown server error. Those are really bad. You never really want to see those for an API, and so on. So that's what the status codes that come back from the server stand for. Alright, so now that we went over the HTTP verbs, the resources, and the status codes, we need to talk about the industry standard status codes that are returned from a request. So there's standard codes that you should always use for certain types of requests. So a post request should almost always return with a 201 as a successful code, which means that the resource was created. That's what the 201 stands for. So if you go ahead and send a post user to create a new user and the user was created successfully, you should return a 201. If, for example, you sent an invalid request, you would respond with a 400, which means the client sent bad data and the request was bad. If you're trying to create a user where, let's say, the name or the email already exists and somebody's already taken that name or that email, you should always respond with a 409. So a 409 means conflict, which means your data is colliding with another piece of data exactly like it that already exists. So it's a bad request. You need to retry with new data, essentially. The GET request almost always just returns with a 200, meaning success. 200 means okay, so it just means that it was successful and you return the data. If you try to get, let's say, a customer with a specific ID field and that guy has already been deleted or he never existed to begin with, the server is going to respond with a 404 not found, which means we tried to look him up in the database and we just weren't able to find him. So you get a 404. That's what you get. It's an error code on the client side, not the server side, because it was the client who requested a resource that does not exist. Put typically responds with a 200. So a 200 with an OK response, typically it returns the data to you. So if I put the user and I update the user, I expect, if I get a 200 back, I expect to get the updated content back to me in the response. If you receive a 204 from the server, it's essentially the same thing as a 200, except you're not going to get any data back. So it means it was successful, but the server for some reason just decided not to return any data to you. So you should probably fetch it with a GET right after to get that updated data. Same thing with a 404. A 404 means not found. So if you try to update an existing user who is not in the system, you're going to get a 404. Patch, essentially everything I just said for put applies for patch. And delete. I've seen deletes respond with 200s. I've seen them also respond with 204s. So both is standard practice. Either is fine. Some people believe if you've deleted something, there's no point in responding with the data. So just send a 204, which means they were successfully deleted, and just don't return any content. That's fine. And obviously a 404 applies. You can't delete a user if he just doesn't exist or he wasn't found. Alright, so that was kind of a crash course on REST and the basic verbs and the basic status codes. Now I think it would make a lot of sense for us to dive in and try to design a REST API ourselves. So here we are. We have these resources in the backend system, and we need to design an API interface so that clients and other systems can interact with our API. So here are the requirements of the API. Your boss has just come to you and he said the system needs to be able to create products, create suppliers, view all of the products for a certain supplier, view all of the branches, and then view all of the branches but for a certain headquarters. So if we look at the diagram here on the right, It looks like we have products here, we have suppliers, we have deliveries, and so on. So you can see that products are kind of all by themselves over here, and it's nothing more than just a product with a supplier ID. And let's see, suppliers, yeah, so suppliers are another resource that you have a delivery ID. So a product belongs to a supplier because of the supplier ID, so it's pointing to a supplier. A supplier belongs to a delivery because it says here it has a delivery ID, which means a supplier belongs to only one delivery. That's very important here. So a delivery can have multiple suppliers, and a supplier can have multiple products. But a product cannot have multiple suppliers, and a supplier cannot have multiple deliveries. I hope I said that clearly. Also, headquarters have a branch ID. So a branch can have multiple headquarters, but a headquarters can only have a single branch. So it's a one-to-many relationship. This is what they call this in databases. A one-to-many relationship means one resource can belong to multiple other resources, whereas those resources only belong to a single one of the first resource. Alright, so let's dive into it. Let's go ahead and try to see if we can figure out how to do number 1 here. So I'll increase my font size. Alright, so to create a product, what would that endpoint look like? Well, since products are a resource all by themselves, we know it's going to be a post request because post is to create a new item, and I believe just a simple endpoint such as post products makes a lot of sense. It's very simple. It's very straightforward. Remember, the whole idea of REST APIs is they should be simple so that they should explain themselves. You shouldn't have to ever explain how a REST API works. It's kind of like the reason why REST was invented. It's supposed to be extremely simple and extremely easy to understand for somebody who just reads the documentation for the system. Alright, so I think post products makes a lot of sense for creating a new product. Let's see, how about creating suppliers? What do you guys think? So if you're creating a supplier, yeah, it looks like I can create a supplier simply by using post suppliers. Pretty straightforward. One thing to remember is with REST endpoints, you should always use the plural version of the resource. So products, not product, and suppliers, not supplier. Number 3, view all of the products for a certain supplier. So this is where REST conventions really come in handy. So REST always assumes you go from the higher level like resource in terms of like relational structure down to the lowest resource. So remember how I said that a supplier can have multiple products, but a product can only have one supplier? Well, if I want to view all of the products for a certain supplier, I would typically write the endpoint like this: get/suppliers, the ID for the supplier, and then products. Number 4, view all the branches. Simply get branches makes a lot of sense here. And number 5, just like number 3, if I want to view all the branches for a certain headquarters. So first I'm talking about the headquarters. I say, hey, for this specific headquarters, so get headquarters with an ID. I want to see all of the branches for that headquarters. So this is how you typically write REST APIs. So you write them in a way that describes the relationship. So I can look at this REST endpoint and I can already assume, without even looking at the database, that, hey, a headquarters has branches, and suppliers, they have products. Now, let's just give one more example here. We'll call it number 6. Let's say view a specific branch for a specific headquarters. What do you think we'd do here? Would we say get a specific branch for a specific headquarters? Is that what we would do? Although this might technically work, it's not the most proper way of doing it. So what we should do is we should go headquarters, then go into the branches resources under headquarters, and then get a specific branch with that branch ID. So now if we were to implement this system and give this REST API to our clients, to our other systems that are going to interact with us, they would very easily be able to say, okay, well, post products, that creates a product. Same thing with suppliers, and same thing as all the GET requests. It's very straightforward what they're doing. There's really no description required. So yeah, so all in all, this is how you design a REST API with the different HTTP verbs, with the different HTTP status codes, given a certain database layout and a certain set of requirements for what the system needs to do. I hope this was helpful. Make sure you like and subscribe to see some of my other videos. And yeah, I hope this was helpful. Thanks.